All right, hi, thanks for coming by. Do you want to start off by introducing yourself and what you work on?
Definitely. Thank you for having me here. My name is Shubhankar Tripathy. I graduated from UMass and my research area is on reinforcement learning. Currently, I'm working on multi-agent reinforcement learning, and my idea is how we can make it more applied and use it on different domains.
Yeah. Are you presenting work here this week?
I am giving talks which is unofficial right now. We are having workshops which is unofficial on Luma, but we are planning for the papers next NeurIPS.
Okay, cool. Well, is there some interesting work in progress that you want to share?
Definitely. So currently, I am working on how we can use multi-agent RL in the finance domain, and we want to find out that how can you use this new agentic AI workflows. There's a lot of hallucinations and a lot of the inferences that can come out is not very aligned well. So we want to create a RL environment where the agents can be controlled on the basis of rewards and action state. And I can say that with a very good authority, the initial experiments are going really well, and we are ready to test on some of the real data sets, right?
Is your goal eventually for them to be able to make a lot of money, or like playing the stock market or something, or is it other kinds of environments?
Making a lot of money doesn't hurt. So if that happens, that really well. But the real experiment here is financial market is a domain where there is a lot of randomness exists, a lot of stochasticity. So if we are able to perform in the stochastic environment well, then we can translate it to different domains as well. That would be less stochastic.
What other domains are you excited about?
In terms of material engineering, where there are a lot of constraints in terms of fluid dynamics, like when a plane is flying, there is turbulent situation. How do you make autopilot makes decisions? So these are some of the domains. How to create new approximations in different unsolved differential equations. So these are some of the domains where the multi-agent RL systems can actually be really, really good in terms of decision makings and finding the approximations. So it's kind of making it more applied, like using reinforcement learning in a more applicable way, because right now everyone is trying to find that how can we expand and scale RL.
Yeah, what do you think is special about multi-agent RL for these domains as opposed to like sort of the existing ways, for example, that autopilot is done, or existing ways that we do approximations for finding various solutions of things?
So the inspiration comes from the fact that if I am like you go to a school, right, and you do not get taught by a single teacher. You get taught by different teachers on different topics, which is why you have different classes, different experts, and you learn, right? So when an agent is asked to solve one particular problem and give one particular reward for one specific problem, the idea is like it doesn't scale, or it won't be able to capture the intricacies of it. So that's why having different agents in different environments where the real life conditions are changing, so different agents can actually take different controls and they can collaborate among each other so as to find the most optimized solution possible. That I think is the goal, and to our experiment it is going pretty well right now.
Cool. What do you think is the biggest barrier to getting these to work in more domains?
Biggest barrier here is to understand the intricacies of the problems involved. And without having a very good grasp of the domain expertise, it is very difficult to understand the nature of data that is needed, the nature of understanding the problem, the nature of how do you craft a objective. These are really, really open-ended environments where it's very difficult to actually understand that, like what exactly fits this.
Yeah, so do you think like if the challenge is really understanding what the nuance of the domains is, like do you think that, next like 2, 3, 4 years, as more of these systems end up being usable in different places, that we'll need sort of different domain experts to shepherd like, okay, the multi-agent systems for this domain and then different domain experts for these other domains? Or do you think that there's a way to maybe algorithmically or methodologically figure out how to get things to work in multiple places at once?
That's a good question. There are definitely similar domains where a technique called transfer learning is being used. So as long as we are able to figuratively and with a guarantee prove that the hypothesis that we are working on works in an acceptable way in one particular domain, we can definitely use to transfer it to a different domain which closely aligns with the current one. And in that progression, as we can see from the classical machine learning on how it was initially used, and right now everywhere it's being used in the embedded systems, in the IoT and everywhere. So that might be the possibility. Like multi-agent right now is very much baby, I would say, but as it grows, as it expands, I have a good feeling that it will expand. And I'm saying that RL is not the end of the world, and there would be different learning algorithms that would come along with it on top of it, or in an adjusted or adapted way. So it would improvise and evolve as the nature of research and development goes on.
So 5 years, what's your ideal future?
5 years, I see myself to be an entrepreneur professor or entrepreneur researcher. Professor would take me a PhD, so I don't have a PhD yet. So maybe in 10 years it would be entrepreneur professor, but in 5 years definitely an entrepreneur researcher. And I would be able to contribute to the human kind in a way that actually would make a lot of lives better.
Nice. That's a really nice way to end. Yeah, thanks for coming to chat with us.
Thank you so much for having me here.
Yeah.